Imagine standing right in the center of a $5 billion downstream oil refinery mid-construction.
Oh, that is a massive scale.
Right. You've got like 10,000 workers swarming the site. There are 50 cranes swinging steel through the air, and just millions of moving parts converging in real time.
It's an incredible amount of activity.
Exactly. So for you listening, picture this. If a pipe fitter drops a custom-made wrench or, a sudden rainstorm halts welding for 3 hours, who actually pays for that lost time?
Yeah, that's the big question.
How does the entity financing this sprawling metallic city ensure the budget doesn't just completely spiral out of control into utter chaos?
Well, to the untrained eye, a mega project just looks like a symphony of pure, unadulterated chaos. I mean, it really does.
Oh, totally. Just sparks flying everywhere.
Right. But beneath the physical reality of sparks and cranes, there is a hidden architecture, a deeply complex, ruthlessly enforced paper architecture.
Which brings us to our topic today. For you, the listener, we are embarking on a custom-tailored deep dive into that exact paper architecture.
It's going to be a good one.
We've got a stack of highly technical documents in front of us, known as the FIDI Red Book Construction Contract. And we're specifically focusing on the unit rate schedules and preambles today.
Yes, the real nuts and bolts of it all.
Our mission is to basically decode the meticulous, almost obsessive language of project costing and measurement that keeps these massive engineering feats on track. And to do that, I've brought in the ultimate guide. You are going to help us translate this dense contractual matrix into the real-world mechanisms that govern mega projects.
Well, I'm looking forward to it because what's fascinating here is that these documents, these preambles and schedules, they aren't just administrative spreadsheets.
Right, they're much more than that.
Exactly. They form the supreme rule book for allocating risk on a massive scale. I mean, they literally map physical reality into a highly specific alphanumeric code.
It's like looking at the receipt for a sprawling city, but this receipt also tells you exactly how much effort it took the chef to cook the meal, clean the kitchen, and, take out the trash.
That is a perfect way to put it. It translates the sweat of a worker and the exact tolerances of steel into a legally binding financial metric.
Okay, let's unpack this. Because before we can talk about the cost of building, we have to understand how a project is even categorized.
Right, the foundation.
The contract anchors everything to a 7-level WBS. Now, we see the work breakdown structure all the time in project controls, but the FIDI preambles seem to dictate a level of granularity that borders on the extreme.
It really does.
I mean, every single physical object or action gets a unique identifier. Can we walk through the mechanics of how the 7-level structure actually maps the physical site?
Sure. So it functions like a geographical and metallurgical funnel. It starts broad and zooms in with just terrifying precision.
Terrifying precision. I like that. So where do we start? Level 0.
Right. Level 0 defines the asset itself, say a downstream facility. Then level 1 isolates the area.
Okay, so breaking it down geographically.
Exactly. So if your code is OR1, you are OBL, meaning outside the battery limit. If it's OR2, you're IBL, inside the battery limit.
Gotcha. So instantly the risk profile is established because, working inside the main processing area carries entirely different logistical constraints than just working in a support yard.
You hit the nail on the head. Then we hit level 2, which identifies the specific component, like a distinct processing unit or building.
Okay. And then level 3.
By level 3, we isolate the discipline. So you'd see PA for pipework, ME for mechanical, or A for instruments.
That makes sense. But it's level 4 and level 5 where the document stops being a map and starts dictating the actual physical labor.
Precisely. Level 4 locks in the exact material or grade. Code P01, for example, dictates carbon steel. P005 is super duplex stainless steel.
Wow, okay.
And then level 5 tells you the specific activity being performed on that exact material.
Give me an example of an activity.
Well, Activity 107, for instance, isn't just a generic labor code. It specifies the preparation, cutting, and beveling of a pipe at a fabrication shop.
Which brings us to the final 2, level 6 and level 7.
Right. Level 6 provides the description, and level 7 dictates the item size.
So a completed code might end in, 120 for a Schedule 120 thickness and 0.18 for a 14-inch diameter pipe.
Exactly. That full 7-level code tells you everything about that one piece of work.
Okay, I have to jump in here and push back on this a bit, because as I was reading this, I just kept thinking, if I am the prime contractor, doesn't managing tens of thousands of these 7-level alphanumeric codes create an absolute administrative nightmare?
It definitely seems like it.
Right. Why not just bill the client for installing the cooling water pipe system. Why do we need a unique barcode for the act of beveling a 14-inch carbon steel pipe inside the battery limit?
It looks like administrative overkill until the moment something inevitably goes wrong or changes.
Changes.
Exactly.
No.
If we connect this to the bigger picture, this level of granularity is the ultimate safety net for both the employer and the contractor when dealing with change orders.
Because things always change on a mega project.
Always. On a multi-billion-dollar build, the design will change. Ground conditions will force a pivot. If you only build for installing the cooling system and the employer decides to move a pump station 50 feet to the left, how do you value that change?
I see. It becomes a massive project-killing legal dispute.
Exactly. Without the matrix, a change order is just two executives screaming at each other over a boardroom table.
Right, which nobody wants.
That's the historical alternative. But the preambles explicitly state that if a new item is added to the scope of work, its financial rate must be calculated from a similar, analogous item already priced within this 7-level WBS system.
Okay, so if the employer says, hey, we actually need this run of pipe to be 16 inches instead of 14 inches, the contractor can't just opportunistically invent a wildly inflated new price.
No, they cannot. They are forced to look at the WBS, find the labor and material rates for the closest analogous 14-inch item, and mathematically derive the new price based on pre-agreed metrics.
Wow. So the code neutralizes the emotion. It prevents chaos. So the WBS perfectly identifies the object. It essentially assigns a hyper-specific barcode to every single physical action on the site.
That's a good way to look at it.
But a barcode doesn't protect a budget if the price tag attached to it keeps fluctuating based on reality. How does this contract lock down the actual financial cost of that barcode?
That brings us to Section 1 of the preambles, and specifically the mechanism of the composite rate.
Yes.
It's often summarized by two of the most heavily loaded words in the entire construction industry, supply and install.
It sounds so innocuous. You know, hey, can you supply this valve and install it?
Does it sound simple?
But when you read the fine print, those two words form a massive, frankly intimidating financial umbrella.
Yeah.
I mean, when a contractor prices a unit rate under this system, they aren't just pricing the chunk of metal and the hourly wage of the guy bolting it in.
Far from it. The composite rate must secretly absorb all overhead, profit, management, supervision, and design engineering.
That's a lot to bundle into one number.
And it goes deeper into the physical execution. It must include shop drawings. It includes all non-destructive testing, or NDE.
Like X-rays.
Yes. Taking X-rays and gamma rays of welds to prove their structural integrity requires halting work, setting up radiation barriers, and bringing in highly paid specialists.
Oh, wow.
The cost of all that testing and the delays it causes is baked silently into the linear meter rate of the pipe.
And the staging. I noticed the rate has to include scaffolding, weather protection, pollution screens, and safety barricades.
All of it.
The text even dictates that the composite rate includes the provision of quarantine facilities for materials that need to be strictly segregated on site.
Yeah, you have to account for everything.
I kept thinking of it like booking an all-inclusive resort package. If I hire you to supply and install a door at my facility under this contract, you can't come back to me later and charge a separate invoice for the screwdriver you used.
Yep.
You can't charge me for the diesel it took to drive to the site. You definitely can't charge me for the broom you used to sweep up your own sawdust. It is all internalized in that one composite number.
That is exactly the intended mechanism. The preambles state that quantities, rates, and prices are fully inclusive regardless of, and I'll quote the text directly here, difficulty, location, complexity, and whatever method the contractor may adopt.
Wait, forcing a contractor to eat the cost of bad weather or, like, a welder having a slow day seems incredibly one-sided.
It is very strict.
If I have to rebuild a massive scaffolding structure 3 times because of high winds, or if my laser-guided robot breaks and I have to use a guy with a handsaw, the rate is the rate. The employer doesn't pay a cent more. So how does anyone actually make a profit under this red book?
Well, that is the multi-million-dollar question. The answer is that contractors operating at this tier have to be elite estimators.
They really have to know their stuff.
Yes. They build risk premiums into their bids. They use historical data to predict exactly how many days they will lose to wind or how many welds will fail X-ray and need to be redone.
So they're playing the odds.
In a way. The employer is buying a finished product in place, transferring the risk of execution entirely onto the shoulders of the contractor. If the contractor is more efficient than their estimate, they make a massive margin.
And if they aren't?
If they are sloppy, they absorb the bleed.
Man. Okay, so I tried wrapping my head around the measurement section next, and honestly, the logic seems wildly inconsistent across different trades.
It can definitely look that way.
Like, steel gets measured by weight, but piping completely ignores weight and just uses a tape measure down the center. Why the discrepancy? Here's where it
Well,
gets really interesting, because the contract dictates totally different physical realities for different disciplines.
that's right. Each discipline has its own unique set of preambles tailored to how that material behaves and how it is fabricated.
So let's look at structural steelwork first.
Okay, so steelwork is measured in net tons. The contract even forces a standardized density to use if a specific weight isn't available, 7,850 kilograms per cubic meter.
Right.
But the contractor faces immediate margin squeezes here. For instance, they get no allowance for rolling margins.
Okay, let's explain that, because for the listener, that's huge.
Right.
When a steel mill rolls an I-beam, they have a manufacturing tolerance.
Right.
The beam might actually be, say, 2% heavier than the theoretical weight in the manual. The contractor has to buy that physical heavy beam from the mill, but they only get paid by the employer for the theoretical weight. They buy heavy, but bill theoretical.
Exactly. They also get no allowance for the weight of the weld metal they add to join the beams and no allowance for waste disposal.
Just absorbing more and more cost.
Yep. But the rule regarding voids is where the labor calculation really comes into play. If you cut a hole in a steel plate to let a pipe pass through, you do not deduct that empty space from the measurement unless the hole is larger than 0.10 square meters.
At first, I thought, why would the employer pay for steel that isn't there? But it's about the labor, right?
Exactly.
Cutting a tiny, precise hole in a thick steel plate takes significantly more man-hours than just leaving the plate solid. So the contractor gets to keep the square meter rate of the missing steel to offset the intense labor of cutting the void.
It's a pragmatic compromise. Now, contrast that with pipework.
Right. Piping is totally different.
Yes, piping is not measured by weight. It's measured in linear meters along the center line. It goes right through all the elbows and T's.
But not through inline equipment. I noticed the text specifically states you measure the pipe up to the flange of a valve, but you stop. You don't measure through the valve.
Correct.
Because the valve itself is a totally separate WBS item.
Exactly. And the testing requirements in the pipework preambles are famously stringent.
Oh, the hydro testing.
Yes. When you complete a pipe system, you have to hydro test it. You pump it full of high-pressure water to prove it doesn't leak. The preamble dictates the rate for this testing includes as many fills of water or air as are required.
Wait. As many fills as required. That is brutal.
It really is.
I mean, you test it, it leaks, you drain thousands of gallons of water, grind out the bad weld, re-weld it, and refill the entire system.
Yep.
And you don't get a dime for the second fill.
Or the third.
You just bleed man-hours until it passes, all under that original composite rate.
It forces a culture of do it right the first time.
Clearly. What about civil and earthworks?
If we look at civil and earthworks, the act of carving out the foundations for this sprawling facility, the transfer of risk is just as heavy. The excavation rates per cubic meter must include the cost of upholding the sides of the trench with shoring so it doesn't collapse.
Makes sense.
It also forces the contractor to absorb the bulking and shrinkage of the soil.
Because when you dig compacted dirt out of the ground, it expands, it bulks. You have to pay trucks to haul away a larger volume than the hole you dug.
Exactly.
And when you pack dirt back in, it shrinks, requiring more material to fill the same space. So the contractor has to accurately forecast the geotechnical properties of the site's dirt before they ever put a shovel in the ground.
Right. They have to know exactly what they're digging into.
Oh, and the dead services rule. I have to mention this. If you're excavating and you hit a 50-year-old abandoned concrete pipe, under normal circumstances, you'd halt work and issue a variation right.
Normally, yes.
But under these preambles, the rate explicitly says removing dead services is already included in your price per cubic meter. You just have to rip it out and keep moving.
It forces the contractor to conduct exhaustive site surveys before bidding.
I guess so.
Another great example of this enclosed risk is insulation and painting.
Right. Because if I'm painting a massive pipe rack 40 feet in the air, I don't get to go find a separate WBS code to charge the client for building scaffolding.
No, you do not.
The general preambles are airtight on this. Temporary works and access platforms are strictly deemed to be included in the rates for the permanent work. You are selling the client a painted pipe. How your painters get 40 feet into the air safely is your logistical problem and your cost to bear.
Exactly. And the painting rate also includes solvent washing, masking off adjacent equipment, And testing ambient weather conditions.
Testing the weather.
Yeah, if the humidity is too high, you wait, but you don't get paid to wait.
Incredible.
To bring this all together into a tangible, high-stakes scenario, we should look at the nervous system of the project. We've talked about the brute force of steel and dirt, but the WBS Discipline Code, NN Instruments, deals with the highly sensitive, highly calibrated brain of the facility.
This section blew me away. I was reading through the unit rate schedule table for instruments. You have the WBS level codes, the description, the unit, the quantity, and the composite rate in euros.
Right.
But then it breaks that composite rate down further into 3 distinct columns: material cost, labor cost, and finally, man-hours per unit.
That man-hours per unit column is critical. That is the employer demanding to know the exact assumption of human time the contractor is relying on.
Why do they care about the exact hours if it's a fixed composite rate?
Because it is a metric of pure productivity. If a contractor claims they can install an instrument in 2 man-hours and the industry average is 8, the employer immediately knows the bid is fundamentally flawed or the contractor is planning to cut corners.
Ah, it's a sniff test.
Exactly.
And the devices in the 900 series supply and install instrument devices are incredibly complex. We're talking about Coriolis flow transmitters, ultrasonic flow elements, process gas detectors. These are highly sensitive, wildly expensive pieces of equipment.
And installing them isn't like bolting a bracket to a wall. The instrument preambles detail a massive amount of hidden labor.
Such as?
The rates must include handling fragile capillary tubes without kinking them. They demand strict humidity control during storage. You can't leave a Coriolis flow transmitter in a dusty laydown yard in the rain.
Right, that would destroy it.
Yeah, if it degrades, you buy a new one and redo the labor for free.
The preamble also demands pre-calibration, function testing of the loops, and generating calibration reports. You have to mathematically prove the brain is thinking correctly before that line item is considered complete.
This raises an important question regarding the physical architecture. You have all these brilliant, sensitive sensors mounted all over the facility. How do you physically integrate them into the control systems?
That's the 901, 902, and 903 series in the WBS. The hookups.
Right. 901 covers instrument air to valves. 902 is instrument air header to manifold. 903 is instrument impulse tubing.
And they don't just let you charge a generic rate for tubing, do they?
No, they don't. The schedule forces the contractor to price-specific runs: a 5-meter run of 38-inch tubing, a 10-meter run, a 15-meter run. You have to pre-calculate the exact geometry of the hookup.
That is wild. The electrical cabling is even more intense. The text dictates that the length measured for payment is the actual installed pulled length.
Which means the straight line from switchgear A to junction box B.
Right. But if you pull that cable, you need extra length to snake it around corners in the tray. You need tails, the extra meter of wire left inside the massive switchgear cabinet so the electrician can actually strip it and make the termination.
Exactly.
The cost of all that extra wire, the snaking and the tails, must be absorbed by the contractor into the rate of the straight pulled length.
Exactly. If the structural straight line distance is 100 meters, but the electrical foreman knows he needs 115 meters of cable to account for tray drops, snaking, and terminations, the contractor only gets paid for 100 meters.
Wow.
The estimator has to forecast the internal layout of a cabinet months in advance to build the cost of those extra 15 meters of copper into the linear meter rate.
So what does this all mean? When I step back and look at this entire matrix, the 7-level WBS, the composite rates, the absorbed rolling margins, the hidden scaffolding, the pulled length versus actual length, these documents essentially force the contractor to foresee the future.
That is the ultimate takeaway. It forces foresight.
I mean, they have to predict the weather. They have to predict exactly how many man-hours a worker will spend calibrating a single Vortex flow transmitter in the middle of a dusty site. They have to capture the messy, unpredictable, chaotic reality of human labor and physical forces and compress it all into a guaranteed fixed decimal point.
And that is why understanding these preambles is so vital for anyone involved in major capital projects. It gives you the operational framework for how massive infrastructure comes to exist.
It takes away all the excuses.
It really does. It removes the emotion, the excuses, and the variables, leaving only the mechanism of risk and reward. It shows you exactly how human effort is translated into contractual reality.
As we wrap up this deep dive, I want to leave you, the listener, with a new lens. The next time you drive past a towering bridge or a sprawling power plant, don't just see the concrete and the steel.
Look a little closer.
Exactly. I want you to see the matrix. Visualize those 7-level WBS codes floating over the pipes. Realize that every single action, down to the painter's scaffolding, the cleanup of the sawdust, and the X-ray of the hidden weld, it was all pre-calculated.
Yes.
It was assigned a composite rate long before the first shovel ever broke the earth.
Every successful megastructure is a quiet triumph of estimation and risk management.
It truly is.
Yeah.
But looking at how mathematical and stringent this system is leaves me with a final, somewhat provocative thought to mull over.
Oh, what's that?
Well, if we've successfully managed to distill the chaotic, messy reality of human labor, weather, and physical construction into an airtight, 7-level alphanumeric code, a system so perfectly logical and rule-bound, how long is it until artificial intelligence takes this FIDWBS system and simply bypasses humans altogether to automatically bid, design, and manage the mega projects of the future? Is human estimation already obsolete?
Now that is a thought that will keep you up at night. The paper architecture might soon be estimating itself.
Something to ponder next time you see a crane on the skyline. Thank you so much for joining us on this deep dive. Keep questioning the structures around you, keep looking for the hidden rules, and we will catch you on the next one.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.